So today we're still working with our two formulas, our compound interest formula. So we have A equals P times 1 plus R over N to the NT, and we have A equals P e to the RT. And remember, these are both our compound interest formulas. So this is compound interest. And then this is our special one. We have to compound it continuously. We use this formula right here. So these are the two formulas that we're going to use. Now, remember that our A here in both formulas is the amount we want to end up with. P here is our initial investment. Our R's are our rates. T's are our time. And N's, remember, is the compounding rate. So how many times you're going to calculate your interest in a given period. Now, before we have only been solving for A. Today what we're going to do is we're going to be solving for other variables, specifically R and T. Those are the two variables we're going to be solving for. Okay, so let's look at a couple of examples. So we say if $3,000 invested at 8% per year compounded quarterly, how long will it take for the investment to be worth $10,680? So again, just like we're doing the other day, or for the past couple lessons, we're going to list out what we know. So we're going to see, do we know our A, do we know our P, do we know our R, do we know our N, and do we know our T? So here we have if $3,000 is invested. So that's going to be our initial investment, so that's going to be our P, our $3,000. We have our 8% per year. So that 8% per year, remember, is our rate. So that's going to be 0.08. It's compounded quarterly, which means that we're going to compound it 4 times in a year. So our N is going to be 4 here. And then we have this $10,680. And that is what we want our investment to be worth. So that is actually what our A is going to be, our $10,680. That's what our A is, what your ending amount is going to be. So what we want to find is we want to find how long will it take. So this T right here is what we're going to be solving for. Okay, so let's look at this problem. So I know, I'm just going to put these into my formula. I have 10,680 equals 3,000 times 1 plus R over N, or 0.08 over 4 raised to the N, which is 4, times T. So the difference between this problem and all the other problems we've been doing is here, instead of solving for A like in all the other ones, we're going to be solving for this T. So the way we're going to do that is just by solving our equation. And we're going to have to use logs in this because we're going to be solving this exponential equation. So the first thing we're going to do is I'm going to divide both sides by 3,000. And when I divide both sides by 3,000, I get that 3.56 equals, and I'm going to do this 1 plus 0.08. I'm going to do this addition right there, and I'm going to get 1.02 raised to the 4t. Okay? So now I have this exponential equation here. So what I'm going to do, remember if we were solving our exponential equations, we're going to take the natural log of both sides. So now I'll get natural log of 3.56 equals natural log of 1.02 raised to the 4t. So now what I can do, since I took the natural log of both sides, I can bring this 4t to the front. Okay, so then I will get that the natural log of 3.56 equals 4t times the natural log of 1.02. And then I want to solve for this variable t right here. I want to solve for that t. So what I'm going to do is I'm going to divide both sides by 4 natural log of 1.02. Divide this one by 4 natural log 1.02. Over here, my 4's cancel each other out, my natural logs cancel each other out, and I get that this is 16.03 equals t. So I know it's going to take about a little over 16 years for this investment to be worth $10,680. And again, I solved this just like I did, or I set this up just like I did last week. I set up my equation, and then I solve for my missing variable, which is the t. And so when we have to solve for something in our exponent, we're going to have to use our exponential equations. So let's look at one more example. So let's read this problem. It says, at what rate of interest compounded annually should you invest $750 if you wanted to triple in 10 years? So I'm going to find what I know, A, P, R, N, and T, and see if I know any of that stuff. Okay, so it says, at what rate of interest? So it says, at what rate of interest? So that's something that's going to be what I'm trying to find. I don't know what my rate of interest is. Compounded annually, so that means my N will be 1 because it's compounded annually. Should you invest $750? So I'm going to put this, my initial investment of $750, so that's going to be my P. If you want it to triple in 10 years, so I know my time is going to be 10. Now, we know our A, but it's kind of hidden here in this problem. It says here that you want it to triple in 10 years. So if you want your money to triple, that means my A is going to be 3 times 750, or 2250. Because I know that I want my money to triple. So now let's set up our equation. I know I'm going to have 2250 equals 750 plus, or not plus, times 1 plus, and we're trying to solve for our R over 1 raised to the 1 times 10. Okay, and now we're going to solve this just like we did last time. I'll divide both by 750, divide by 750, and when I put it in the calculator, I get 3, and then I'll get 1 plus R to the 10th. Now, remember that when we have an exponent here, we have something raised to an exponent. The way we get rid of that is by raising it to the opposite power. So I'm going to raise that to the 1/10th power. So I'm going to raise both sides to the 1/10th power, because here then I'll get a power raised to a power. Remember, I can multiply that, so 10 raised to the 1/10th give me 1. So those kind of cancel each other out. And then I will do 3 raised to the 1/10th in the calculator and get 1.116 equals 1 plus R. And then to finish solving my equation, I'm going to subtract 1 from both sides, and then I'm going to get 0.116 equals R. So now that's my answer for my R. Now, just to be a little bit more specific in answering my question, though, it says at what rate. So this is a decimal for my rate. So if I want to know actually what rate it's going to be, again, I'm going to move my decimal place over 2 spots, because 11.6 is the same as 11.6%. So I know that would be my rate at which I would need to invest my money for it to triple in 10 years.